All right. Hello, everybody. A while ago, we just looked at division. All right. And before we looked at multiplication, I'm sorry. We're now going to be looking at division. And before then, we had dealt with addition and subtraction. Okay. So for this section, we're going to look at division of whole numbers. Okay. So we are still under the enumeration system. We're looking at numbers basically. Okay. So we're looking at the meaning of division through various models. Okay, the inverse relationship that exists between multiplication and division, just like we did in multiplication. We said that repeated addition is multiplication, and here we're going to look at the inverse relationship that exists between multiplication and division, and special cases of division by 0, by 1, and division algorithms, including the standard algorithm and division of number bases other than base 10. Now, we will look at that briefly, and I'm going to do a separate video on just looking at some examples on division of number bases, but I'll capture it, okay, for a little bit. Okay, now, so 3 models for division. We will look at the set partition model. Okay, the set of elements represent the dividend is partitioned into divisor number of subsets. We'll look at that. And then missing factor, right? The missing factor approach. We'll look at that. And then repeated subtraction, that means what? Division. So here, let's get into it. So number 1, we look at the set partition model. So we look at 18 cookies and want to give to an equal number of cookies to each 3 friends, Bob, Dean, and Charlie. And this is it. Okay, so we partition this into groups, and we realize that we have 6 cookies going to each person, Bob, Dean, and Charlie. Okay, nice. Now the missing factor model, and we are very conversant with this. So we have 3c being equal to 18. So the factor here we want is what? C. So we divide both sides by 3, and 6 cookies will go to each person. So that is why we have 6. Okay. Nice. So that's what we call the missing factor model. And division of whole numbers. For any whole numbers A and B, with B not being equal to 0, we have A divided by B equal to C. If and only if C is a unique whole number, it's like that B times C is equal to what? A. So we say that A over B is equal to C. We are saying B must not be equal to 0, because if B is 0, anytime you divide a number by 0, you have undefined. So A over 0, the answer is not 0. We call it undefined, and we shall look at that. So we don't want the denominator to be 0. So that's why that condition has been stated. And for this, A over B is equal to C over 1, which is the same as C. Okay, I cross product when I'm dealing with proportions. So A is equal to B times C. Okay, and that is what I have right there. So A is equal to B times C. Okay, now the number A is called the dividend. All right, and B is the divisor. So dividend and divisor. So now if I have A over B, which is equal to C, this is the same as doing it in the long division method. You remember that? So this guy, okay, A over B, that means B is dividing A. So, and that should give you the quotient. So we call this guy the divisor, and this is the dividend, and the result is your quotient. And we are going to see how we can use that in an algorithm, okay, to solve problems. Let's see. You look at that briefly and see how that works. And that is written as that. B goes into that. Okay. Now suppose 18 cookies and want a package to be in cookies boxes that hold 6 cookies each. Okay, this is what? Repeated subtraction. So we'll keep subtracting 6 until we get to 0. And our answer is what? 3. So repeated subtraction is also division. Is that okay? So we repeated subtraction is division. Okay, nice. So really, the bottom line, what we wanted to do was that 18 over 6 gives you 3, and that is repeated subtraction. If you keep subtracting 6, okay, get that. Now, given any whole number, A and B, with B not being equal to 0, there exists a unique whole number, Q, right, which is the quotient, and a remainder such that. So let's look at this. Let me use numbers to explain that. So for instance, if I have 4 divided by 2, okay, now let's put this in the long division method, and I'll use that to explain what this means. Okay, this means 2 and 4. How many times can 2 divide 4? 2 can divide that twice. So we do 2 times 4, 2 times 2, that gives us 4. We subtract, and this leaves a remainder of what? 0. Is that okay? So in effect, this is our B, and this is our A, and this is our quotient. Okay, and this is our remainder. So this is our quotient. Let me make it Q, not 9. Okay. Now, what this means is that you realize that this 2 times 2, which is what? B times Q, plus the remainder of 0, which is R, must be equal to RA. Okay, so B plus Q, which is what? 2 times 2 plus the remainder of 0 is equal to RA, which is what? 4. So we have 4 being equal to 4. And that's what this algorithm means. I'm going to use a different set of numbers, okay, that will leave a remainder to explain that to you. So now, if I did 3 divided by 2, if I want to put this in the long division method, 2 goes into that how many times? Once. 1 by 2 is 2. I take that out, I have a remainder of what? 1. So in effect, this guy, this is our B, that is our A, and this is our quotient, and that is our remainder, right? Now, so do you realize that if we do 2 times 1, which is 2 times 1, okay, plus our remainder, which is 1, that will give us our A, which is what? 3. Is that okay? So we have 3 being equal to 3. So if you wanted to put that in the number form, B times Q, right? So that would be B plus times Q plus the remainder, which is 1, will be equal to A. So that is where this algorithm is coming from, basically. Okay, and that is how we use the division algorithm. Okay, nice. So let me clear that. So that is a division algorithm, and very soon we're going to use that to solve an example right here. Okay. All right, so now if 123 is divided by a number and the remainder is 13, what are the possible divisors? So we're going to use that algorithm to solve that. So we call A is equal to what? B plus Q is equal to R. All right, and we realize that B, if it leaves a remainder of 13, that means our B is greater than 13. So you try to simplify So you put the numbers here. So you simplify. So you have BQ being equal to 110. Okay. And then you look at the possible numbers. And here I put that on a table. Now, because we are looking for a number that is greater than 13, this will be our answer. So we see that 110, 55, and 22 are the only possible values for B because each is greater than what? 13. Okay. And that is our answer. And that's how you use the division algorithm to solve examples. Okay. Now let n be any non-zero number. Any number divided by 0 is undefined. Okay, 0 divided by any number is a 0. So note the distinction. And 0 divided by 0 is undefined. Okay, so note these distinctions and don't get confused about that. Okay, now relating multiplication and division as inverse operations. Okay, so the inverse of addition is subtraction, and the inverse of multiplication is what? Division. So this is a table that represents the inverse relationship between these operations. Okay, and repeated subtraction gives you division, and repeated addition gives you what? Multiplication. Interesting. Okay, and we dealt with this when we're looking at exponents under the previous section. And if two exponential numbers are dividing and they have a common base, what you do is you take the exponent of the denominator from the exponent of the numerator, and that simplifies that. Okay, and then using base 10 blocks, and you know how to do these kind of divisions. We've dealt with the long, the units, okay, and then so block, units, long, and flats. We've dealt with these in our earlier sections. So these are very simple and straightforward. Okay, now here, this is the same long division method, the division algorithm that we dealt with here. So you want to know how many times 6 can divide 726 using the long division method. So now you decide to do 100. There are 100 times 6, so that gives you 600. You subtract and that gives you that. All right, and then you realize that 10 by 6, if you take that out, so you do systematically until you get your answer. Now here, if you put these numbers together, that should give you 121. Okay, so there are two different approaches. I'm sure you are much conversant with this, so either of these work. So this is just the long division approach in using long division. And here is the same approach, okay? And we look at base 5 multiplication, and we have looked at base 5 multiplication in the previous section. Okay, so that is that. So we need this in order to do our division of base 5. Is that okay? And I'm going to do a video on how we can do division with number bases. And this works just like the previous example we looked at, okay, the number of hundreds that are there in 600, okay, and all that. So I will look at a video, I'll do a video on that. And here, when you put all these numbers together, that should give you 34, all right? You can as well do that. And it leaves a remainder of 14. Okay. So these are mental mathematics division, breaking up the dividend. So if you want to break up the dividend, so here you break this and that up. Okay, so you have 8 divided 5, 6, 4, 8. You break that up, so you have 5,600 on one end, and then you have 48 on one end. Now 8 goes into that 700 times, plus 8 goes into 48 6 times. You put that together, and that gives you 706. Okay, this is a very nice technique. Okay, and using compatible numbers, we've dealt with that as well. So you have 105, so you break them up. Now, how many times can 3 divide 90? 30 times. How many times can 3 divide 15? 5 times. You add, and that gives you 35. Okay. And again, using compatible numbers. Okay, so you break them up and you do the division, and that simplifies that. It's still compatible numbers. Okay. All right. Now you talk about the order of operation, and I'm sure you are familiar with this guy. So parentheses, exponents, multiplication, division, addition, and subtraction. And that is the order of multiplication. Okay, so thank you very much for your time. And this is the end of 3.5. Okay, thank you. See you. Bye.